So for this question, we're going to do addition and subtraction problems with scientific notation. So the first answer they want us to put into kilograms. So first we have to make our units equal, right? Because we have kilograms here and grams here. So let's take our grams divided by 1,000 to turn it into kilograms. So 2.5 times 10 to the 6th, right? We divide by 1,000. It's going to be 2.5 times 10 to the 3rd, right? 1,000 is going to be 3 units of scientific notation. So take the 6 minus 3. We get 2.5 times 10 to the 3rd kilograms. Now, when we do addition and subtraction with scientific notation, we want to try to get these two numbers to be the same. So if we take, or we turn a 4 into a 3, that would be the same as if we move this decimal place here and we subtracted 1 to make this a 3, and then we get 12.6 times 10 to the 3rd kilograms. So now we have the same scientific notation up here. So 12.6 plus 2.5 is 15.1, and then it's going to be times 10 to the 3rd kilograms. Next for B, they want our answer to be in kilograms. So let's go ahead and turn our grams into kilograms by dividing by 1,000. So 7.06 divided by 1,000, because there's 1,000 grams in 1 kilogram. That's going to be 7.06 times 10 to the negative 3rd kilograms. Again, when we do addition of subtraction, we want these two numbers to be the same. So let's make these both a negative 3. So in order to do that, we need to move the decimal here to the left. So it'll be 0.12 times 10 to the negative 3rd kilograms. Now we have the same, so we can add 7.06 plus 0.12, which gives us 7.18 times 10 to the negative 3 kilograms. Next for part C, they also want the answer in kilograms, so let's go ahead and convert our grams into kilograms. There's 1,000 grams in a kilogram, so we're going to divide it by 1,000, and when we divide by 1,000, we just subtract this number by 3. So it'll be 2.8 times 10 to the 4th kilograms. Then these numbers, right, we need to be the same. So let's turn this 5 into a 4 by moving the decimal place to the right. So it'll be 43.9 times 10 to the 4th kilograms. Now these two are the same. So we'll take 43.9 minus 2.8, which is 41.1 times 10 to the 4th, which we can again move this over here. So we just get 1. So it's going to be 4.11 times 10 to the 5th kilograms. Which, let's fix number A, I forgot. So we left it as a 15.1, but in scientific notation, right, we need to have a single digit and then the decimal. So we're going to move it 1 to the left, which is going to be 1.51 times 10 to the 4th kilograms. Okay, so then in part D, we need to convert it into grams. So let's just first do the calculation with kilograms and then convert it into grams. So we need the -1 and the -2, right? They're different. We need them to be the same when we do the subtraction. So let's rewrite the first one. We'll move the decimal place to the right, so it'll be 53.6 times 10 to the negative 2 kilograms, right? let me just show it out so you can see how these are the same, right? So we have 5.36 times 10 to the negative 1, right? That's the same as saying, we move the decimal place to the left, we have 0.536, and 53.6 times 10 to the negative 2, we move it to the right 2 spots, which gives us 0.536, right? So these are the same numbers, but we can write it different ways in scientific notation. So let's finish out our problem. Now that we have the same 10 to the negative 2, so do 53.6 minus 7.4, which gives us 46.2 times 10 to the negative 2 kilograms. And we'll move this over to the left. It'll be 4.62 times 10 to the negative 1 kilograms. We take it times 1,000 to convert it into grams. Or that would be like saying we take this negative 1 plus 3. So your interest would be 4.62 times 10 to the second grams.